You were able to look at those helpful hints solutions that I gave you and were able to make some sense out of what I was talking about. Because what I want to do today is start talking about an actual proof and what it looks like, a statement reason proof. Okay. Now, what I like to use the analogy of a courtroom scene. Everybody's seen a courtroom scene either on television or in the movies. And basically, is you got two sides. You got the prosecution, you got the defense. Each side is trying to prove their case. Okay, they're starting off with a set of facts that have been established, okay, by both sides. Like, let's say, all right, a certain bank was definitely robbed on a certain day and a certain location. Okay, those are given. Those are statements that are definitely true. That's why we're here today. Okay, what each one wants to prove, the prosecution wants to prove that the defendant is guilty. Okay, so they're going to present a set of statements which they call facts. Okay, they're going to be statements, and each fact has to be supported by a reason. They can't just come out and say, oh, he's guilty because we think he's guilty. They got to have a set of facts to back it up. Okay, and on the other side, the defense wants him to be acquitted. So they're going to say, no, my client didn't do this crime, so I'm going to present a set of facts, and each fact is going to be backed up by something, some reason for me saying it. Okay, and what they're trying to do is get the jury to come to the conclusion that they want. You know, the defense wants him acquitted, the prosecution wants him convicted. Okay, so what we're going to be trying to do is we're going to be trying to prove, we're going to start off with congruent triangle proofs. Okay, we're going to start off with a set of given statements, okay, that we know are true about the two triangles. Okay, and we're going to string together a bunch of statements and hopefully come to the conclusion that we want to come to, that the two triangles are congruent to each other. Okay, so the first part of proofs is going to deal with these congruent triangle proofs, and there are 5 different methods of proving two triangles congruent. Okay, the first method that we're going to use is called the side angle side postulate. Okay, and I'm going to show you exactly what this means. Okay, it says two triangles are congruent if two sides and the included angle of one triangle are congruent respectively to two sides and the included angle of the other. Okay, all 6 of one congruent to all 6 of the other. We're going to have to generally show 3 parts of one congruent to 3 parts of the other, and that will generally be enough. Okay, and this first one is going to be called the side angle side postulate. Okay, now I'm going to illustrate why this works. Okay, so suppose I have this triangle. Looks like this. Okay, and then over here, I'm just going to draw part of another one. Okay, and I'm going to show you, all right, this side is congruent to this side. This angle is congruent to this angle. And this side is congruent to that side. Okay, if all of those things stay those lengths and that angle stays that, that size, the only way I can complete this other triangle is to draw this side right here. Okay, and that means that those two triangles will be the same. There's no other way for me to draw a triangle with those two sides the same and that angle the same. Okay, so this is known as the side angle side postulate because we've got this side congruent to this side, this angle congruent to this angle, and this side congruent to this side. Okay, so let's look at the postulate again. Two triangles are congruent if two sides of the included angle. The included angle is the angle formed by those congruent sides. Okay, that's why I'm talking about this angle right here, because that's the one that's formed by the two sides I know are congruent to each other in each triangle. Okay, the included is basically between the two sides, side angle side. So the name itself, SAS, side angle side, tells you exactly where the angle has to lie with respect to the sides in order to use this postulate. The A is between the two S's. That means the angle has to be between the two sides. Okay, so that's the first thing you kind of need to understand here. Okay. Okay, so scroll up to the first example. Okay, this is our first method of proving triangles congruent, side angle side. This is generally what a proof is going to look like. Okay, we have a diagram, we have this triangle ABC, and we have these given statements. Okay, these given statements. AD is perpendicular bisector of BC. So that tells us a bunch of stuff. Okay, and what we're trying to prove is triangle ABD, triangle on the left, is congruent, that's what that little symbol stands for, so get used to seeing that, is congruent to triangle ACD. So what we're going to need to do is we're going to have to write a series of statements along with reasons, like we did on the homework, okay, that are going to lead to that conclusion. And we're going to start off with doing a side angle side, using the side angle side postulate. Okay, side angle side proof. All right, so the first thing I'm going to always tell you to do, okay, is mark the diagram with what you know. Okay, that's going to make it a lot easier to know where to start writing. Okay, so I'm going to look in my givens. AD is a perpendicular bisector of BC. So what does that tell me? All right, well, perpendicular means that there's two right angles there. Okay, AD is perpendicular to BC. It also calls it a bisector of BC, which is going to mean this side is congruent to that side. Okay, so now right off the bat, we've got two sides, one side of each congruent, and we've got an angle of each congruent. Okay, now if you think back to the postulates that I talked about yesterday on that postulate sheet, the very first one that I talked about was the reflexive postulate. And I said, it sounds silly now, okay, but when we start to use it, it won't seem so silly. That one said, the reflexive postulate said, a quantity is equal to itself. Okay, not only is a quantity equal to itself, okay, if I have a line segment, it's congruent to itself, or any angle is going to be congruent to itself by this reflexive property. So what I can say is AD, and I'm going to draw it this way, AD is congruent to itself by the reflexive property. Okay, so now I've got everything I need for a side angle side proof. I've got BD and DC, that's one side of each. I've got angle ADB and ADC, the two right angles, those are congruent to each other. And I've got AD, which is part of both triangles, it's congruent to itself. So what I've got here is side angle side. I've got two sides and the included angle of one triangle congruent to two sides and the included angle of the other triangle. Okay, so since YouTube won't allow me to post really long videos, I'm going to cut this one here and I'm going to proceed with the proof in the next video.